And I'll post all these check your understandings tonight, I reckon. This is on page 121. Here we go. Number one says we've got cholesterol levels above 240 milligrams per. I don't know what that means. What does that mean? What does this mean? 240
per deciliter.
Thank you. I don't do the science. I do the theoretical.
Milligrams per deciliter?
Yeah. All right. What percent of 14-year-old boys we're missing some info.
Yeah,
I would love to know how what this distribution looks like. So I need the information that I need to answer this question is I need to know, is it normal, and what is my mean, and what is my standard deviation?
It's above.
Fantastic. So this is at 170, 30. Fantastic. So then I want to know what percent of 14-year-old boys have more than 240 milligrams of cholesterol. So I'm looking at X equal 240. Right? That's all the information that I need to find this particular proportion. That awkward moment. Okay, so what I need to do then is I need to standardize this value. X minus, remember I'm using this formula, X minus mu over sigma, which is going to be 240 minus 170 divided by what?
Oh my god.
I think that we have gotten rid of the ghost. Okay, here we go. So we need to now find a proportion that corresponds to this. Remember how we're going to do that. We're going to go ahead and go to our table, which I have located in a file right here. No. All right. Breathe. Come on, technology. All right. 2.33. Is that 9901? No.
Yes.
Yeah, 0.9901. All right.
99.
And we want to know how many were below, right? So, then we would say that approximately 99.01% are below. That is what the question was asking.
You need to find a club.
What percent have more than? Okay, so this is the amount that are below. So what did we find here when we found this 0.991? We were actually looking at the area, so 2.33. So we're, I don't know, a little more than 2 standard deviations above the mean. So what we calculated was that area, right?
Yeah.
But it wants to know how many are above. So we need this guy. So what do? We use what's called the complement rule. So we need to actually find out. We actually need to subtract that from 1, which gives us what? Anybody? Something? Calculation?
0.
009? What?
According to the chart.
Oh, you use the. Yeah, cool. Got it. You're integrating this now? Fantastic. All right, cool. It's approximately probably 2 as well, right? And this is also approximate. Apologies for that. That's a big mistake. Make sure that if you are counting that you use the approximate symbol. Otherwise, you're wrong. Oh, all right. What if we were going to find between 200 and 240? So for number 10.
Whoa. Wow.
That actually looks really cool when I did that. All right, for a second. Okay.
4 is
I did some really complicated mathematics last grade. It's a little overwhelming. Pre-AP Algebra 2, but we did proof involving primality of a certain type of polynomial. Actually, it was an exponential. Yeah. All right. So we already know this, right, for 240. So we just need a z-score for 200 because now we're doing number 2. 170 divided by 30 is what? Yeah. Thank you. All right. Let's so let's go ahead and now I'm going to show you a different way to do this, not using the table. I want you to know how to use the table in case for some reason your calculator malfunctions or something happens, right? On the AP test, you'll always have that table. Actually, if your calculator malfunctions, but now that I think about it. But anyways, I want you to also have another approach to it. So if you like a technological approach, you can look at your calculator. So go ahead, and guys, on your calculator, if you just hit this calculator button, no matter what you're doing, if you just need to make a simple calculation, hit the calculator button right below the escape button, and it'll just give you a calculator right away.
Scratch that.
Yeah, for scratching. All right, so you would think that you would go to statistics, right, when you hit menu?
False.
But you do not. You'll be going to probability. So hit menu, probability, and we are going to go to distributions.
It's also under statistics as well.
It is? Okay.
Go to probability, then distributions.
Well, yeah, normal CDF. Sorry, I accidentally hit plus on. CDF. Yes, I will actually be able to tell you once I enter the command. All right, so we're finding an area. So your calculator is going to say lower bound and upper bound, okay? So check it out. If I am finding an area from here to a point, right? Then my lower bound is going to be that 9e to the 999th power. That's about as close to negative infinity as your calculator can get a grip on, right? That's why that's what it is, right? Because really, when you're integrating this, you're integrating from negative infinity to a point. That's really what the mathematics that's going on behind it. So what are we finding? We are indeed looking for, and let's look at what is the area that we're looking for? We are looking for between 240 and 200, which is actually above our mean, right? So we're actually trying to find as one standard deviation above my mean. Picture's probably not good. But that is the shaded area that we're looking for, right? We're looking for approximately this shaded area. How are we going to get that? Well, we can get that by finding the area from this point, right? And subtracting from it the area from this point to the left. Does that make sense? Yeah? Okay. All right. So now we're going to find a value for this. So in other words, we're going to be integrating from, so we're actually finding this proportion here. So we're going to find this area piece, right? So what that means is that we are actually finding an area going from negative infinity, roughly, right? All the way up to 200 on this thing. So that means that my lower bound is going to be that negative 9 e to the 999, right? My upper bound will be 200. Mu is given to us as 170. And sigma is 30. I plug in, I say, okay.
Wait, what's the
Upper bound is the x value. So in this case, that would be 200.
And then what's the mu?
It's given already. That was 170. Okay, for those of you that are trying to do this bad boy on an 83, 84, whatever you're doing it on, it's not an Inspire. This is what you're going to enter. Norm. CDF. You can get to this, I believe, by getting your distribution button, going to normal CDF. But all it's going to do is put this norm CDF on your screen, right? If you have a non-Inspire calculator, it's going to put this on your screen. This is what you're going to enter every time. Your lower bound. Upper bound. X, mu, sigma. Much more complicated to do. Your lower bound, you can use, I believe on an 84, you can use, yeah. That is going to be your X value. The upper bound is your X value. All right, so what did we get for this? This proportion was 0.841. Okay, or let's see, we'll go 1.3 because I think we have 4 digits on our other one. All right. So what is this area then? It is going to be so this is actually going to be equal to this little area is 0.9901 minus 0.8413. Yeah.
the whole hassle of subtraction and just make your lower bound equal to 30.
Yeah, absolutely. Yeah, so you could change your lower and upper bound and not do the subtraction, but I wanted to show you how you could do it with just your table. So if you just had your table, you wouldn't be able to switch that. You'd have to do the subtraction. But then again, right, like you're pointing out, if you're doing this on the calculator using normal CDF, which I imagine most of you guys will now probably wind up doing, you can use your lower bound as 200 and your upper bound as the 240. Same mean, same standard deviation. It will give you the same one. So try that, right? So try it. Try to do now. Make a new calculation where you change your lower and upper bound, and you should get. Well, let's go ahead and calculate this point. 9901 minus 0.430. Yep, so you should get the same thing that way. So I'm just showing you a few different approaches to get the same answer. It's always nice, I think, to have options. Huh? That's what most about those things. I don't agree with it in that context. Yes. Jordan. Huh. Okay. And then what if we needed to find the 80th percentile? Well, we could do as we did yesterday, right? And go to the table, right? So let's look at the table way. So, and what were we talking about here? It was. Anyways, we want to find what value. So for 3, we're trying to find what value would be at the 40th, or was it the 80th percentile?
It says a Tiger Woods driving.
Because it's referring to a different data set. Yeah. So for 3, Tiger Woods drives. How are they distributed?
It's 304 and then 8.
And 8?
Yeah.
Okay. So that is the distribution of Tiger Woods driving distances. And we want to know what value, what X value is at the 40th percentile. So let's go, or it was 80th. Right. Okay, well, I could use the table approach. And wait, let's give it a sec. Yeah. Okay, let's go to the table. Let's find a z value for the 80th percentile. Z value, the standardized value, 80. Ooh, which one's closer? This one. So 0.84 would be our z value. Yeah? So remember, when we're going from percentile out, we're going to calculate our percentile. We're going to look for the percentile. So in this case, it's young. And then that means that I'll be at 0.84. So I'll have a z value of 0.84. So that gives me z equals 0.4. All right? And that's all fantastic news, but I'm gonna have an equation to solve. So this is one of the few times in this class when you will do algebra, but we're going to do some algebra. All right? So what I'm being asked for is, hey, if I have a z-score of 0.84, what x value will I get with a mean of 304 and a standard deviation of 8?
Multiply by 8.
Oh, cool. The counselor was calling. I don't know if you want to check in on that at some point. That is a take-home quiz. Oh, okay. Did anyone solve this right away? No? I guess I'll solve it. So, I will multiply both sides by 8, right? We're solving in proportion. 8 times 0.84 is 6.72. Sorry. I calculate using the robot voice. So, this is going to be x equal to, when I add 6.7, or so when I add 304 to both sides, I get 310.72. So, you would say, a 310.72 yard drive is at the 80th percentile. Boom. We done checked our understandings.
What about 8%?
Huh? And yeah.